I was truncate this. Oh, there we go. Started it. Everybody, welcome to the. It's really just very basics of this tech meeting, just to get everyone kind of on the same page, on the same level, understanding. If you have any questions during this, feel free to shout it out, raise your hand. Doesn't matter. Don't worry about talking over me, whatever you need to do. So let's just jump right into it. So biggest, highest level thing with Distech is that there are essentially two different environments. So there's the physical environment and the software environment. So the Distech box, the actual physical computers manufactured by Distech. And then the Niagara or N4 is the software. That's the company that makes software. So Niagara owns Distech at this point, but there's still that slight difference in the terminology. Let's start out talking about the Distech boxes. So there are many different models that Distech makes, but for this specific meeting, we're going to talk about the Bayer models. And so we're using three types of Distech boxes for this project. There's the ECB VAVs up top, ECB 300s in the middle, and EC Boss 8s, or sometimes referred to as JACEs, in the bottom there. And so the VAVs and the 300s are the controllers. These are the actual things with the pins that will be receiving and sending electrical signals to field devices or from field devices. And the EC Boss 8, or the JACE, is the device that interfaces with Delta V specifically and has the ability to convert different communication protocols to whatever we need. So really all the configuration that the JACE needs is when we receive it, we configure it, we give it an IP address, and we send it on its way. It does not need anything else. It's a very smart computer, and we'll talk a little bit more about the setup for that later, the further setup, the field setup. And then for the controllers, all you need is a MAC address for those that's unique for that particular network that they're on, because they're all daisy chained together. We'll talk about that later too. And it needs a unique code downloaded to that specific computer, which we'll also get later. So let's get into the networking side of things. Each controller is wired for different tasks. So a lot of them are wired very, very similarly, and they have the same pins and the same communications to the same type of devices. Like the most common one is just the power in and the network in. It's like 180 of the 200 that we have, or just that type. However, they all communicate on the same daisy chain. So Stock and Austin, I think there are like anywhere from 12 to 20 parts for around 200 of these devices. So there really aren't that many daisy chains. They're all connected pretty much. They all come into the same network too, but we'll go over a little bit more specific networking stuff in the next few slides. So they're all daisy chained off a BART or MOXA. So all the VAVs and ECB 300s will be connected through a BART. All of the flow transmitters will be connected through a MOXA. And all that does is change the wiring, in particularly for the BART. It changes it from MSTP wiring to Cat6 wiring. It's still BACnet protocol, but changes the wiring. And for the MOXA, it changes RS-232 to Cat6. So after it goes through the BART, which changes the wiring, the Ethernet wiring for the BACnet can interface with the JACE. The JACE then changes the protocol from BACnet to Modbus. And then that talks to the PK. PK talks Modbus TCP. And then if you want to send a command, it's just the exact opposite. PK sends Modbus TCP to the JACE converts that to Modbus, or JACE converts that to BACnet, BACnet sends to the BART changes it from Cat6 to MSTP, sends it to the VAV command.